Now we're going to talk about how to integrate power functions. So if we have a function whose derivative is t to the power of n, where n is a constant, what we would like to find is the function that produced that derivative, or more precisely, all the functions that could produce t to the n as a derivative. Well, we should go back to our power functions and try to differentiate them. So if we have t to the n and we take a derivative, we get n t to the power n minus 1. Next thing what we want to do is, let's divide everything by n, both parts. We can do that. In this case, we're going to get 1 over n, t to the nth power, prime equals t to the power of n minus 1. Now, we remember that we can take a constant and put it inside of differentiation, because derivatives don't care about the constants. So we're going to get t to the n divided by n prime equals t to the power of n minus 1. Okay. Now, what we can do, to make this look prettier, what we're going to do, we're going to replace this n minus 1 with k. In this case, n will become k plus 1. And our formula becomes looking like this. So what does it tell us? It tells that if I have a derivative of a function equal to t to the power of k, in this case, so if I have some function g prime as tk, in this case, my g is tk plus 1 over k plus 1 plus arbitrary constant. All right? Or if we go back to our original variables, we don't like k, we want to use n, we say this. Okay? And that's a formula to use to find how to integrate power functions. So now if somebody comes to you and says, okay, I have my function f as t to the power of 15. All right, why not? Sorry, if you have f prime as t to the power of 15, you say, well, your f gotta be t to the power 16 over 16 plus some constant. All right. Again, that power doesn't have to be integer. It could be anything. If somebody tells you your f prime is, I don't know, 1 over square root of t, which is t to the power of minus 1/2. In this case, f that produced that derivative is t to the minus 1/2 plus 1 divided by 1 minus 1/2 plus 1 plus an arbitrary constant. In other words, it's f t to the power of 1/2 divided by 1/2 plus constant. In other words, it's 2 times square root of t plus arbitrary constant.